Okay, this is the waveform for the schoolgirl with the skateboard wheel. Let's see, bottom is the amperage, top one is the voltage. It's running on a 9-volt battery, and it's also charging another 9-volt. We have it tuned to resonance right now. It runs about 100. It was running about 150 before we tuned it to resonance. Should be about double, about 300. That's the voltage it is right now, 7.84. We started out at 8.29 about 20 minutes ago. And that's the wheel right there. It's got 4 magnets. It also has some 1/4-inch wide filament tape wrapped around the magnets, so we have a safety in case it flies out. The shaft is a 5/16 hardened drill rod. It's 0.312 normally. We sanded it down in the drill motor with a sanding disc belt sander to about 3.09. So you get a little more clearance, so the bearing can float at high speeds on that shaft and possibly alleviate some of the misalignment of the bearings. Also possibly float on the shaft if the bearings have more drag. This is counterclockwise coil, 1 turn of number 23, 1 turn of number 26. It's 500. What is it here? 573 turns. Neodymium magnets to reset the magnetic core. These are 1/8 inch thick magnets, 3/4 inch in diameter. They also have a hole in them. So that is about 1.25 inches. That's the circuit. Now we found out from some tests from other circuits we built with the schoolgirl that if you take this, this is a TO3. It's a 2N3055. It's one of the transistors John Bedini used to use. If you mount this is bolted right to a polycarbonate sheet, 90 thousandths thick. There is no mica washer here. It just bolted right to the polycarbonate. We also have, that is the socket there, the TO3 socket. We'll put those socket on the YouTube list of it. Anyhow, what happens is if you put this heatsink, or put this transistor on a heatsink, depending on the size of the heatsink, we had a fairly massive heatsink. The voltage increase was so great of the flyback that we had to put another battery to charge another battery through the to the diode circuit of some of the John Bedini's advanced stuff. This was designed for the schoolgirl without any charging capabilities, but just by mounting this transistor on a heatsink, the flyback was so great that the neon light came on. By the way, there was no neon light on the original schoolgirl because he didn't need it. So you mount that transistor on a heatsink, you're going to get more flyback. You need to charge a battery with it. You can't get by without some way of harnessing that energy, that flyback, because it will eventually burn that transistor out. That's why we have the neon even on the schoolgirl. This is the base current light. It's a 6-volt 150 milliamp incandescent bulb that's in series with the R2 resistor. It basically will tell you if you're drawing a lot of current into the base. Now this one transistor unit will not even turn that light on, so you don't really need it on this circuit. You start running multiple transistors, you're going to need some indication you've reached a high level of current through the base transistor. That's one of your indicators. We also put a on and off switch on here so you could spin it up and then turn the switch on real quick. That's a 10-turn pot here. That's a Fender guitar dial. It's got the numbers on it. So all that will be listed on the YouTube video. This video is part of a book we're drafting right now, how to build all the specs on it. So it'll all be in the book. So there you have it.